Alright, so on the T7 notes, I'm going to start down here. My whole goal for tangent, secant, cosecant, and cotangent is that if I give you the graph, you would be able to identify what function it is. Okay, so like if I gave you a cotangent graph, could you tell me that it's cotangent? That's the goal. Okay, so we're going to go through and just talk really quickly about what each of these graphs look like. What's going to help you in this section is to just quickly sketch your points around the unit circle for those quadrantal angles. Okay, so for example, if I were you, I'd go ahead and make a note of where 1, 0 is, where 0, 1 is, where negative 1, 0 is, and where 0, negative 1 is. Okay, that's what we're going to be using to help us fill out these charts. Okay, so I'm going to look at the first one. The first one's tangent. I'm going to do the first one with you guys. Let's see. So here's my bigger drawing. I'm going to start with negative pi over 2. Negative pi over 2 is this down here, right? And tangent, remember, is y over x. Right? So I'm going to be using that information here. At negative pi over 2, my y over x is negative 1 over 0. Right? Negative 1 over 0 would be undefined, right? Anything divided by 0 is undefined. Okay. Then I go to negative pi over 4. Negative pi over 4 is going to be my 45-degree reference angle, which remember the point on the unit circle is radical 2 over 2, negative radical 2 over 2. Okay, so here if I do y over x, what would I get? Campbell, what would my y divided by x give me? What's anything divided by itself? 1, okay, and then we have, so it would be negative 1. Yep, perfect. Okay, so then I go to 0. What would that be? Kristen, what would that be? Yep, 0 over 1 would give me 0. Yep, that's my y over x. Okay. Then I go to positive pi over 4. The terminal side is right here. So that's the point, radical 2 over 2, radical 2 over 2. Column, what would that be? 1, yep, y over x. Anything divided by itself is 1. And then at pi over 2, that's this 90-degree angle. What's my y over x there? Kyle, what would that be? You can tell I'm just kind of like snaking. Maybe what? It would also be undefined. Excellent. Okay, so we're just using those points to help us get our outputs there. What should I graph where it has a y output of undefined? What do you see on your graph? Yeah, go ahead. It will be an asymptote. Great. So I'm going to draw an asymptote at negative pi over 2. I'm also going to draw an asymptote at positive pi over 2. Okay. And then I'm going to plot these points. Negative pi over 4, negative 1, 0, 0. Pi over 4, positive 1. And the tangent graph is going to increase from left to right between those asymptotes. Remember, vertical asymptotes, you cannot cross or touch them. Okay, so you can get infinitely close to the asymptote, but never cross an asymptote. Okay, so I want you to draw your graph where those ends are getting really, really close to your asymptotes. Okay, remember this will repeat infinitely in both directions. So I'll have another asymptote here. I'll have another asymptote here, etc. Okay, it's going to keep repeating. It's going to go from a y value of negative 1 to 0 to 1, negative 1 to 0 to 1, etc. Any questions about the tangent graph? So we're going to repeat that same process for secant. So I'm going to go back to, these values around the unit circle. And we're just going to pick up where we left off. So Jackson, I'm going to pick up with you. Secant, remember, is 1 over cosine, right? And what are your cosine values around the unit circle? Or just what is cosine? Is my x or y value? It's x. So I'm just looking on my unit circle at doing 1 over my x value for each one of those angles. Okay, so if I start with 0, what would that be? What is 1 over x? 1 over x would be 1 over, my x value is 1 here, right? So it would be 1. Okay. What about at pi over 2? Jackson, what would 1 over x be at pi over 2? Undefined, right? 1 over 0 would be undefined. Very good. Okay. And then Mara, at pi, right over here, what would 1 over x be? Negative 1. Excellent. 3 pi over 2, that's going to be down here. 1 over x, let's pop up to the front. Nathan, what would that be? What's 1 over x at pi? 3 pi over 2. That's undefined. Great, because you're right, it'd be 1 over 0. Okay, at 2 pi, we're over here at this point. What would that be, Kyle? What's 1 over x? 1. Great, 1 over 1 is 1. 5 pi over 2, we're back up here. Okay, you can probably see the pattern. 1, undefined. Negative 1, undefined. 1, what do you think that's going to be? Undefined. Negative 1, undefined, etc. Okay, just a pattern. So again, everywhere I see undefined, I'm going to put my vertical asymptote there. So pi over 2, undefined. 3 pi over 2. And 5 pi over 2. Okay, and then I have a point at 0, 1. Pi, negative 1. 2 pi 1. 3 pi, negative 1. And you can see how this pattern is going to repeat. So really there's going to be another asymptote here. And if I want to put another asymptote here, that's going to help me complete my graph. Bless you. I fill up my graph. All right, so now let me show you what this looks like. When you have a secant graph, it's actually a series of parabolas, and they're going to alternate. One's going to open up, then the next one's going to open down. One's going to open up, then the next one's going to open down. So here, I want to fit parabolas within these asymptotes. So one opens up, the next one opens down. One opens up, the next one opens down, and just etc. Right? Extends infinitely in both directions. And I really struggle with getting my secant graph mixed up with my cosecant graph. So this is how I remember where each vertex is of my secant graph. Does everyone agree that secant is a reciprocal of cosine? Right? So watch what happens if I graph my cosine graph. My cosine graph starts at 1, a y value of 1, right? And cosine goes 1, 0, negative 1, 0, 1. This is my cosine function. See how the crest and trough of the cosine function connect with each vertex of the secant graph? That's how I remember where each vertex goes from the secant graph. Okay, I just graph cosine, and then for every crest, I make a point, every trough I make a point, and then that's where your parabolas are going to extend from. Does that make sense? Okay, so now let's go ahead and go down here to the cosecant graph. I'm going to do the same thing that I just did. You can see I don't have an XY chart there, so let's go ahead and make our own. Trying to get you away from me having to give you the XY charts. So we'll have 0, pi over 2, pi, 3 pi over 2, 2 pi. We're going to go around the unit circle for cosecant. Remember, cosecant is 1 over sine, and sine, those are your y values on a unit circle, right? So I'm doing 1 over y on my unit circle. All right, who did I leave off with? Belle, I think you're up. So if I'm doing 1 over y for 0, what would that be? Undefined. 1 over 0 would be undefined. Great. Okay, so now I'm going to pi over 2. That's up here. What's 1 over y? 1 over 1 would be 1. Great. Okay, at pi, what's 1 over y? Let's see, let's come up, Jared. Go ahead and give me that. What's 1 over y at pi? Undefined. Great. 3 pi over 2. Jake, what would that be? 1 over y. Negative 1. Great. And at 2 pi, 1 over 0. Again, that would be undefined. Great. So again, let's graph our asymptotes. Everywhere it says undefined, so that's going to be here, here, and at 2 pi. Okay. And then we've got a point at pi over 2, 1, 3 pi over 2, negative 1. Okay, you can guess how this is going to extend infinitely in both directions, right? We're going to keep, I'm not going to fill up the whole chart myself, but you're going to keep repeating the asymptotes and keep repeating those alternating dots, up, down, up, down, up, down. Okay, and cosecant is also a series of parabolas. So we're going to have the first one opens up, then the next one opens down, then the next one would open up, then the next one would open down, etc. And again, to remember where each one of those, each vertex is, all I'm going to do is graph the sine graph, and you're going to see that the crest and trough of the sine graph connects with the cosecant graph. So sine graph goes 0, 1, 0, negative 1, 0. So see how those connect? Okay, that's how I keep track of where the parabolas are stemming from. All right, the last one is cotangent. Cotangent is the reciprocal of tangent. So tangent's y over x, and cotangent is going to be x over y. Okay, so I'm going to start at 0. X over y at 0 would be 1 over 0, which is undefined. Yep, Kristen?
So I have a question for the last one.
Yeah.
How did you get undefined for 0?
So for 0, we're looking at cosecant as 1 over y. My y value at 0 is 0.
Okay.
So if I do 1 over 0, that's where I got undefined. Yep. Okay. All right, so number 5, we just did x over y at 0. So x over y would be 1 over 0. So again, that starts with undefined. Okay, then I go to pi over 4. Let's see. Lauren, I think I left off with you. At pi over 4, right here, what is x over y? 1. Good, I think divided by itself is 1. All right, and then pi over 2, what would my x over y be? 0. 0 over 1 is 0. Okay, at 3 pi over 4, that's over here. Malika, what would that be for my x over y?
-1.
Negative 1. Excellent. Okay, and then at pi, what would that be, Remy? Undefined, right? Negative 1 over 0 is undefined. And you can probably guess how this pattern continues. Then we're going to have, again, 1, 0, negative 1, and undefined. Okay. So I'll have 0 undefined. At pi, it's undefined. At 2 pi, it's undefined. Okay. And then I'll plot these points. Pi over 4, 1. Pi over 2, 0. 3 pi over 4, negative 1. Cotangent falls left to right and approaches the asymptote. So that's different than tangent, right? Tangent rises left to right. So we'll repeat that here. And these shapes would extend infinitely in both directions. Okay. But pay close attention to the differences. See how this has an asymptote at 0 and the graph falls left to right? Does tangent have an asymptote at 0 or on the y-axis? No, tangent does not have an asymptote on the y-axis, and that one rises left to right. So just be noticing those differences. Again, I want you to be able, if I give you a picture of a graph, to identify which graph it is. That's the goal. I actually wrote at the bottom of my note sheet, just as a reminder, that all graphs extend infinitely in both directions. You guys probably know that, though, so you don't have to write it. You know it. All right, guys, just a couple of quick examples before we jump into the back page. We, in previous classes, have solved equations similar to this one, where if I was presented with an equation like this, I would need to get theta by itself, so I'd use sine inverse to undo the sine function. So we would have theta equals sine inverse of 2/3, something that looks like this. And we'd ask ourselves, okay, this was a positive ratio, 2/3. So where is sine going to be positive? Well, sine's going to be positive in quadrants 1 and 2, so we would have multiple answers. Okay. I'm going to compare this example to something like x squared equals 4, where again, if you square root both sides, you would get plus or minus 2 as your answer, so you'd have multiple answers. Anytime you're writing in the inverse yourself, you're going to see that we have multiple answers, right? Like here I had to write sine inverse in myself. Here I had to write the square root in by myself, and so I had multiple answers. Now take a look at square root of 4. What is the square root of 4? The square root of 4 is just 2. We're just looking for the principal root or one answer here. Do you see the difference? When I wrote the square root in myself, I had 2 answers. Where the square root was already written in for me, I only had 1 answer. Kind of works that way with arc sine or sine inverse as well. See how here I had to write it in myself, so I had multiple answers. Whereas here, sine inverse or arc sine is another way to write that, is already written in the problem for me, so I'm only going to have 1 answer here. Okay? There are going to be restrictions about what quadrants your answers are going to lie in, and we'll talk about that on the top of the next page. So don't be confused. If you are putting in the sine inverse, then you have multiple. If the problem gives you that notation, then you only have 1. So it says notation, arc sine of m and sine inverse of m. These are the same thing. We've seen this in the past. If it says arc, that's all it means. You're just finding sine inverse, sine to the negative first. Okay? Arc sine is the same thing, so don't be confused. It says you are looking for a single angle with the ratio m. Okay, so we're going to be finding a single answer today. It says for arc sine, arc cosecant, and arc tangent, the interval for answers is negative pi over 2 to pi over 2. And hopefully this feels familiar to you. I put the picture up on the board the other day that looked like this, where it was negative pi over 2 to pi over 2. Remember me drawing that picture up on the board? And I had listed next to it arc sine, arc cosecant, arc tangent. And actually I think I had listed sine inverse, cosecant inverse, tangent inverse. Okay, same thing. If the answers are from negative pi over 2 to pi over 2, what quadrants would your answers, or could your answers be in? Either 1 or 4, right? Your answer would either be in quadrant 1 or your answer would be in quadrant 4. For arc cosine, arc secant, and arc cotangent, the interval for the answers is 0 to pi. So that looks like this. 0 to pi. So what 2 quadrants could your answer be in? 1 or 2? Yeah. Okay. Because we're just learning this today, I'm going to include this snippet right here on your quiz, so you don't have to memorize which ones go for what interval. Okay? As long as you know how to apply it, then that's what I'm looking for. Yeah?
You said which of the 6 go in which? Like the cosine, cosecant, where did they all go?
So arc sine, arc cosecant, and arc tangent go on this interval.
Okay.
So that would be sine inverse, cosecant inverse, and tan inverse. Right? And then for this interval, the 0 to pi, it says arc cosine, arc secant, and arc cotangent. So this would be cosine inverse, secant inverse, and then cotangent inverse. Okay? All right, so looking at this first example, it says arc sine. As soon as you see arc in the problem, how many answers are you going to have? 1. Okay. So what I'm going to start with is I'm going to start by determining what quadrants this could be in. If it's arc sine, my answer is either going to be in quadrant 1 or 4. Right? I'm choosing quadrants 1 or 4 for where my answer is going to show up. Because sine is negative, what quadrant am I going to use? Where is sine negative? Quadrant 1 or 4? Sine is negative in quadrant 4. So that's the quadrant that I'm going to use if I'm picking between those two options. Okay, so I'm going to build a triangle in quadrant 4, and that's because sine is negative in 4, right? Sine is negative in quadrant 4. And I'm going to fill out my triangle. Opposite over hypotenuse. The side opposite is 1, and the hypotenuse is 2. Okay. So what would my reference angle be here for this triangle? 30 degrees, okay. Or pi over 6, right? If I don't specify whether I want your answer in degrees or radians, your default is radians. See these intervals? See how it says negative pi over 2 to pi over 2 and 0 to pi? Those are in radian form, okay? So if you see the word arc, I want you to default to giving your answers in radian form. Yes? It should be in radian form, because that's just what the restrictions are listed as. So just put radians. So now here's the other question I have for you. Looking at that restriction for arc sine, can I put 11 pi over 6 as my answer? That would be the terminal side for the positive angle, 11 pi over 6, right? You cannot put 11 pi over 6 as your answer here. Okay, if you do, it's wrong. And that's because 11 pi over 6 does not fall within this interval. Does everyone agree that 11 pi over 6 is not between negative pi over 2 and pi over 2? What answer would be in that interval from negative pi over 2 to pi over 2? Negative pi over 6. You got it. Yep. All right, so let's try that again with cosine. Okay, so now we're doing cosine inverse or arc cosine. Arc cosine, the answers can either be in quadrant 1 or 2. So I'm asking myself, should my answer or should my triangle be drawn in quadrant 1 or 2? Where is cosine negative? Quadrant 1 or 2? 2. Okay, so if I'm choosing one of those quadrants from 0 to pi, I'm going to build a triangle in quadrant 2 because cosine is negative in quadrant 2. Okay. It tells me my adjacent length is 1 and my hypotenuse is a length of 2. So adjacent is a length of 1, hypotenuse is a length of 2. That would leave the remaining side to be a length of square root 3. Right? So what is my reference angle here? Cross from square root of 3, 60 degrees, or pi over 3. Okay? So the terminal side for that triangle is in the second quadrant, so that should be 2 pi over 3. Okay? Does 2 pi over 3 fall within the interval from 0 to pi? Yeah, so you're good to go there. Okay. Looking at tan inverse, I'm doing the same thing, trying to figure out which quadrants my options are. Let's see, arctan, we're either going to use 1 or 4. So my option here is 1 or 4. All right, that goes from negative pi over 2 to pi over 2. In which quadrant, 1 or 4, would tangent be negative? 4. Right, it's right here. And it gives me that the ratio of the side lengths is negative 1. So if you want to write that out as negative 1 over 1, right? Does everyone agree that that's negative 1? That's your opposite over adjacent for tangent. What kind of triangle is that if my opposite length is the same as my adjacent length? 45, 45, 90, right? Opposite over adjacent. That's going to be an isosceles triangle. So here my reference angle is pi over 4. Now, what answer am I going to put for theta? Kristen? Excellent. Negative pi over 4. Negative pi over 4 is your answer. If you put 7 pi over 4, it is true that 7 pi over 4 has that terminal side in the fourth quadrant. However, it's not in the interval from negative pi over 2 to pi over 2. I need answers in that interval. Okay? I forgot to write in here that tangent is negative and 4. Okay, that's why we chose 4. All right, I'm going to do one more with you, and then I'll have you try a couple on your own. Okay, so arc secant of square root 2. Where do we see arc secant? What are my options? 1 or 2? 1 or 2. Okay. We're going from 0 to pi. Everything's positive in quadrant 1, right? So if we're looking where secant's positive, I'm going to construct a triangle in quadrant 1. And I'm going to make, let's see, this would be hypotenuse over adjacent. Right? I'm going to make the hypotenuse a length of square root 2, and the adjacent side is length of 1. Okay. What kind of triangle is that? 1 what radical 2? 1, 1 radical 2, right? 45, 45, 90. So to get that terminal side in quadrant 1, my answer would be pi over 4. Okay. Go ahead and try numbers 5 and 6 for me. See if you can get numbers 5 or 6. Those are a little bit more difficult. All right. Anybody run into any problems? There's a couple of difficult things about these two examples, 5 and 6. Okay, so I wanted you to start by saying arc sine or sine inverse is either going to have an answer in quadrant 1 or 4, right? 1 or 4. And because sine is negative, I'm going to build my triangle in quadrant 4. Sine is negative in quadrant 4. Okay, so I go ahead and build my triangle in quadrant 4. And I'm going to list the opposite side length as square root 2, and the hypotenuse is a length of 2. Opposite of the reference angle is square root 2, and the hypotenuse is 2. Okay, now you might be saying to yourself, okay, that doesn't look like a 30, 60, 90, or 45, 45, 90 triangle that I'm used to, right? Normally I'm used to seeing 1, 1 radical 2, or 1 radical 3, 2, right? But that doesn't really follow either one of them. Okay, thank you. So in order to figure out what kind of triangle we have here, it might be helpful to figure out what this third side length is. Let's go ahead and choose the Pythagorean theorem. Square root of 2 squared plus b squared equals 2 squared. That's going to be 2 plus b squared is 4. So if I subtract 2 on both sides and then square root, I'm going to get the length is square root of 2. So what kind of triangle is that? 45, 45, 90. See how now it's an isosceles triangle? 2 of the side lengths are the same length. Okay, so that's how I know it's 45, 45, 90. Question?
Well, how kind of but technically the negative radical 2 over 2 and just like rationalize.
Yes.
So you could just say it's negative 1 over radical 2.
Absolutely. So I had someone in my vel yesterday do it that way as well, where you just, I don't know whether to call it unrationalize it or derationalize it. I don't know what the proper term is, but basically get it into the form before you rationalized it. And if you put it into this form, then it's going to build a triangle that you're familiar with, right? Because if you put it into this form, then the opposite length would be 1 and the hypotenuse would be the square root of 2, which then you can see it would be a 1, 1 square root of 2 triangle, a little bit easier. So that's perfectly fine. Yes, that is another way to get it. Excellent. Okay. Either way, we know that the reference angle is pi over 4. And since it's in the fourth quadrant, I'm going to make that negative pi over 4 for my answer. Arc cosine of negative 1. Cosine is arc cosine is between 0 and pi, so that's going to be quadrants 1 or 2. Because it's negative, I would say that cosine is negative in quadrant 2 if I was going to pick one of those. Okay, so I would have this terminal side. Okay. And so far we're okay. And then I say, okay, arc cosine's negative 1. I'm going to put this over 1 just to make it into a fraction. And this will be the length of my adjacent side, and this will be the length of my hypotenuse. What problem do we run into? Adjacent over hypotenuse is negative 1 over 1. Do you see a problem yet? If not, you can go ahead and finish building your triangle. Adjacent's 1 and hypotenuse is 1. What's wrong with that? Kristen, what's wrong with that? Yeah, you cannot have a hypotenuse that is the same length as one of your legs. Okay? Hypotenuse is defined to be the longest side. So that does not work. Okay? You cannot build a triangle like that. So exactly, it would be one of our quadrantal angles. So I'm going to think about the points around the unit circle here. I have the point 1, 0, the point 0, 1, and the point negative 1, 0. And I'm asking myself, where is cosine negative 1? Or where is my x value on the unit circle negative 1? It would be right here, right? My x value is negative 1 at pi. Okay, so you should have gotten pi as your answer there. And pi is included in that interval for arc cosine. See how for arc cosine, where is it? Arc cosine, the interval is 0 to pi, and these are brackets. Those brackets are inclusive. So you could have 0 or pi as an answer. Okay, so just keep that in mind. All right, any questions about that? Yeah?
Well, up at the top was where you were like filling in the blanks or whatnot.
Uh-huh.
You were going to make it stop.
Yes, that's correct. Yep, so this right here. Yep, you got it. All right, so here's what I want you guys to do now.